Hello, in this video, we'll be solving four interesting problems. The first question is to find the solution set of the rational equation, and the second one is to find the solution set of this rational inequality. Question three, if A is a solution set of this rational inequality and B is the solution set of these we can say this is an absolute value inequality. Then we want to find what is what A intersection B. Then lastly, question number four is to find this is to solve this radical equation. We will start with question number one. So question number one, what to do in this type of problem is we try to factorize the right hand side. So this is 4x, x minus 5 minus x plus 1. And this we can factorize it or we can leave the numerator as it is. But for the denominator, clearly we can see that this is nothing but x minus 5, then what? X plus 1. Because if you take 5 and 1, minus 5 times 1 will give us we need factors for minus 5 and we need for minus 4. So we need two factors we can multiply to give us minus 5, and when we add it will give us minus 4. And this is nothing but minus 5 and plus 1. Okay, so now before we continue, we have to make some observation, very important. And here we can see that x, the denominator, look at what we have. The zeros of the denominator cannot be solution. So x cannot be 5. Also, x cannot be minus 1. Because if x is equals to 5 or x equals to minus 1, we'll have 0 in the denominator. And that will make this problem undefined. Now, what is our LCD? You take the LCD. We have how many factors? Just two factors. So the LCD is just x minus 5 and x plus 1. So let's multiply this equation, both the left-hand side and the right-hand side. We multiply by the LCD. Okay. So x minus 1, x plus 1, then times 3x squared plus 3 over the same. Now, this x minus 5 will go with x minus 5. So x plus 1 will go with x plus 1. This will go with this totally. So from the first time here, we just have 4x multiplied by x plus 1. So this will be 4x squared plus 4x. Then minus. Here, what is left is just the minus will go in. So you have minus x plus 5 equal to, then the right hand side, we're left with just 3x squared plus 3. So we can simplify this as 4x squared plus 3x plus 5. It's equals to 3x squared plus 3. We can bring these terms to the left-hand side. So you have 4x squared plus 3x plus 5 minus 3x squared minus 3, all equals to 0. And we can try to simplify 4x squared minus 3x squared. So we have just x squared. And the term with x, we have just 3x. So we have plus 3x. And the term without x is 5 minus 3, which is plus 2, equals to 0. And this we can factorize as x plus 2. and x plus 1 equals to 0. So from here, we can say that it means, using our zero product principle, it means that either x plus 2 equals to 0 or x plus 1 equals to 0, or both of them could be 0 as well. So here we have x equals to minus 2, or what? X equals to minus 1. But here, we already see that from the beginning, we say that x cannot be minus 1. So this has to be rejected. So we reject this one. Then now what is left is just x equals to what? Minus 2. So the solution set for this problem is just minus 2. Okay, now that's the end for first question. Then question number 2. Question number 2 is a rational inequality. And how do we solve rational inequality? We use what we call the critical value method. And here, so all we need to do is the first step, it's already factorized. Both the numerator and the denominator, they are already factorized. So we just need to get the critical value. So the critical value here from the numerator, the critical values are the values that makes the numerator 0 or the denominator 0. So it means the zeros of either the numerator or a 0 of what? The denominator. So from the numerator, we can see that x equals to 2 is a 0. Here, this is what? This is x squared plus 1. So we don't have a real 0 for this. So you don't have to worry about it. Then go to the third term here. We can get x equals to what? 3. Then come to the denominator. We can get x equals to 4. Then we just go to the table directly. And this is how the table will look like. We put the zeros from starting with the smallest one, which is 2, followed by 3, then finally 4. Okay. Now, one thing to observe here is that from the procedure of this critical value method is that when you come to the table, you have to open the zeros coming from the denominator. So denominator, the 0 we got from the denominator is this one. So it means we will open 4, right? Then we have two zeros from the numerator. Now, this ones too will be close here at 2 and 3. Why? They are coming from the numerator, but because there is equal to 0, so it means this expression can be 0. So that is why we are closing at 2 and 3. But if there is no equality, let's say it's only greater than, then we don't need to, then we have to open both 2 and 3. So, okay, now let's put our factors. We have x minus 2 to power 7. Then here is x squared plus 1. Then we have x minus 3 plus 4. X minus 3 to power 4. Then lastly, we have 4 minus x to power 3. Now, don't forget that this is like minus infinity and this is infinity. So we can make this table easier if we look at this one. The even powers will be positive in all the interval because the power is 4. And also this second term, which is x squared plus 1. X squared plus 1 is always positive. So this is going to be positive, 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 positive as well. So it doesn't matter what is x. If x is negative, by the time you square it, it's positive. And you're adding 1 again. So it's always positive. So we have reduced the factors now. Now, you just pick a number here. Pick a test point between minus infinity and 2. Between minus infinity and 2, what is any real number here? We can take 0. 0 is fine. If you test 0 here, 0 minus 2 is going to be minus 2. Minus 2 to power 7 is definitely a negative number. Then between 2 and 3, we can take 2.5. 2.5 minus 2 is 0.5. 0 is a positive number to power 7, so this will be positive as well. Then between 3 and 4, we can take 3.5. 3.5 minus 2 is also positive, so 2 power 7 is still positive. Then here in this interval between 4 to infinity, we take 5. 5 minus 2 is 3. 2 power 7 is positive. We are not interested in the value. We're not interested in the quantity. We're interested in the what? In the sign. So now let's come to the last factor here, which is 4 minus x. So take any number between minus infinity and 2. We can still use 0. 4 minus 0 is 4. 2 power 3 is a positive number. Between 2 and 3, we can still maintain 2.5. 4 minus 2.5 is negative. Minus 2.5 is 1.5, which is still positive. 2 power 3. So this is still positive here. Then 3 and 4, we can take still 3.5. 4 minus 3.5 is 0.5. So here is still positive. Then between 4 and infinity, we chose 5. 4 minus 5 is a negative number. 2 power 3 is still a negative number. So this is what we have. Now, if we put the signs together, we'll see that here should be minus. What do you mean putting the sign together? Just follow here. We have, this means that this is minus. Minus times what? Times plus is minus. Times plus again is minus. Then you divide by this one because this is the term here, which is positive in this case. So it will be minus. Here, everything is positive. So we'll have positive. Here is also positive. And here it's negative. Okay, so we're done with the table. Then we just need to pick what? We need to pick the interval where we have this one, greater or equals to 0. Greater or equals to 0 means it's either positive or it's 0. Now, if you look at this interval, we have between two close, yes. By the time we keep going, even up to 3 is still positive, right? At 3 is 0, so it's fine. 3 can be in the interval. Then up to this point is still positive until you get to where you get to 4. 4 is open, so it means we have from 2 to where? Up to 4. Sorry, from 2 to 4 open. But you can see that from 4 to where? From 4 to infinity is minus. Another way we can write this is what? Is from minus 2, sorry, from 2 to where? To 3 close. Then union. Already there is 3, so you can say 3 open to where? To 4 open, which is still the same, but I prefer this one here. The first one is better. Okay, I think this is solution for question number 2. Now let's move quickly to question number 3. Now, question number 3 has two parts. The first part is to find what? The first part is to find A, and the second part is to find B. Okay, so let's find A. What is A? A is this rational inequality, 2 over x less than equals to x over 2. So this is a rational inequality. So what do? We transfer the right hand side to the left hand side because we cannot multiply by LCD in this case because we don't know what is x. X is not positive. So since we don't know what is x, then let's use this method. This is 2 minus x over what? 2. This is greater or equals to 0. So this is how you solve every rational problem. Transfer to one side, so you have 0 on one side, the right hand side. Now this one, you can try to find the LCD here. What we can do, the LCD is going to be 2x. So we can try to make the LCD the same. We can do that by multiplying the first term by 2 by 2. So this is like multiplying by 1. And this one we can multiply by x over x, and this is x by 2. So this is this. So this is like multiplying by 1 here. X divided by x is also multiplying by 1 here. But here we must, we know that now. Okay, let's just, this is what? This is 2x. So now here initially, okay, this should be, let's see what's happening here. What's the first term here? This is 2 over x. So 2 over x, so this should be 2. This is the original one. So the original one is 2 over x, yes. So we just multiply by 2, right? So I think it's fine now. So this will be 4 over what? 2x minus, this is x squared over what? 2x greater equals to 0. So now we can put them together so that this is now 4 minus x squared over what? 2x, since the denominators are the same. And now we can factor this as what? Difference of 2 squared, x minus 2, 2 minus x, 2 plus x over what? Over 2x greater equals to 0. Okay. Now, this is still rational inequality. So from here, we can get our critical values. What are the critical values? X equals to what? X equals to 2 from the numerator, and x equals to minus 2 also from the numerator. But if you look at the denominator, what will make the denominator 0 is x equals to what? 0. So you don't need to worry about a 2 in the denominator. It's just a number. So in the same way, we will still come back here and draw the table, just similar to what we did just now. The critical values, we start with the smallest, minus 2, 0, and what? And 2. And now we can draw our line here just to create this demarcation. So the zeros of the words coming from the numerator, since we have equal to 0, we have to what? We have to close. So we close minus 2 and we close 2. But the 0 coming from the denominator is x equals to 0. So we open this up. Now let's put our factors here, which is 2 minus x and what? 2 plus x. And the denominator, what we have there is just 2x. You can write it as 2x, or you can just put x there. It won't affect the sign. Now let's do the sign test for this. You take a number between minus infinity and minus 2. This is going to infinity. So if we take a number, let's say minus 3. If we take minus 3, what do we get? Come here. Here you will have 2, but x is minus 3. So it will become 2 plus 3. So this will become plus here. And here you have 2. You're taking minus 3. So this will be negative. And this will also be negative. So the result is going to be positive here. Negative, negative, positive, negative, negative will give you positive. Now, between minus 2 and 0, between minus 2 and 0, we can take minus 1 as our test point. You mean in this interval, you can take minus 1 and see. If you put minus 1 here, 2 minus minus 1 is going to still be positive. But here, 2 minus 1 is still going to be positive here. Then you put minus 1 times 2. This is going to be minus. So eventually, we're going to have minus here as well, here. Then between 0 and 2, we can take 1 as a test point. 2 minus 1, this is going to be also positive. 2 plus 1 is positive. 2 times 1 is positive. So this is still positive. Then between 2 and infinity, we can take 3. 2 minus 3, this is definitely negative. 2 plus 3 is positive. And 2 times 2 is positive. So this will still be negative. Now we're going to take the interval where we have greater or equal to 0. Don't forget, this is where we have. So it means our A is going to be from minus infinity to minus 2 close, right? Then where do we have again? Union. Now we have what from here? 0 is open, so it means 0 to 2 close. So this is our set A. Now, what next is to find set B. So let's look for set B. But what is set B? Set B, we need to solve this inequality. We need to solve this inequality. So let's write the inequality down here. This is minus 3 absolute value of x plus 6 less than 12. This is an absolute value inequality. So here we can take this. So take 6 to the other side. So we have 12 minus 6. And we will have minus 3 absolute value of x less than 6. Now we can divide both sides by minus 3. So we have absolute value of x. The inequality will change. And this will become minus 2. Now, what is this saying? This is saying that what? The absolute value of x is greater than minus 2. And we know this is always true, right? Because don't forget, what is absolute value? Absolute value of x is greater or equals to 0. It means it's always positive, or the smallest it can be is 0. So this statement is always true. And what does that mean? It means our B, which is our solution set, is going to be just the whole of R, which is from minus infinity to infinity. Because any value you take from minus infinity to infinity, if you take the absolute value, you know it's going to be either positive or 0. So which is definitely greater than a negative number. So now we have both A and what? And B. So we're going to find the what? The intersection of A and B. Now, if you look at A, what is A? A is this. Definitely A is the smaller set, and B is the what? The bigger set. So you can see that A intersection B is still going to be the smaller set, which is still going to be A. And this, it's simply minus infinity to close union this. This is still closed. And this is the end of question number 3. So take note, anytime you are intersecting a smaller set and a bigger set, definitely we're going to have the smaller set. So, which is still going to be A. All right. Now let's go to question number 4. Now, question number 4 is a radical equation. And one thing you should note, whenever you have a radical equation and you have the index to be even, so you can see here the index of this radical is even. Even is 2. It means when you find your solution, it's good you always what? You always check the solution to see if it actually satisfies the equation. So what do we do here? To solve this, we can just what? We can square both sides. So if we square both sides, this we have 2, 7x plus 2. Let's square this at the moment. So we have this. Now, what will happen is this, we will have 2 root of 7x plus 2. And here will just be 3x plus 2. But we still have a radical there, so we can square again. So we have and now this 2 will be squared, so you have 4, and this, the roots can go. So this we can expand as 9x squared plus what? This will be 12x plus 4. What am I using here? I'm using the fact that a plus b squared is a squared plus 2ab plus what? B squared. So use a as 3x and b as 2. Now this we can write as 28x plus 8, and this is 9x squared plus 12x plus 4. We can move everything to the right hand side, or we can just move the whole of this, the what we have on the left hand side to the right hand side, so that here we have 0, and now we have 9x squared plus 12x plus 4 minus what? 28x minus 8, and this will be 9x squared. What will be the x? We have 12 minus 28, so this will be minus 16x, then minus 4, right? This is a quadratic equation. Let me just rewrite it. Let's rewrite the right hand side first. Now, this is a quadratic equation we need to solve. So how do we solve this? You can see the coefficient of x squared is not 1, so it means we have to multiply 9 and minus 4, which will give us minus 36, and we have minus 16, right? So we have to look for two factors that we can multiply to give us minus 36, and we add to give us what? Minus 16. So I think we can use minus 18 and what? And 2. Minus 18 times 2 will give us minus 36. Minus 18 plus 2 will give us minus 16. Now, since the coefficient of x squared is 9, we can divide here by 9, right? Divide here by 9. So this will just give us minus 2, right? So this, it means we can factorize this easily as well, as x minus 2. Then we have, from the other side, we should have 9x. 9, this will be the coefficient of x. Here is you can have it over 1. And this is 9x plus 2. Okay. Now, what is left? What does it mean from here? We can see clearly. It means that x is equals to what? 2, or x is what? Minus 2 over 9. Now, can we stop here? No, really, because here we're dealing with what? We're dealing with even roots. And since we're dealing with even roots, it's always good to what? To check. So we will try to check this. So let's do the checking here. The checking simply means you want to be sure if this will be, which of it will be a solution and which one will not be. So let's start with x equals to 2. Now, sometimes you can have 1 because we talked about extraneous solution, right? So extraneous solution will not satisfy the original problem. But let's see here if we have an extraneous solution or not. So let's check. And what are we checking? We just want to be sure that the left-hand side is equals to the right-hand side. Don't forget, what is the left-hand side? Is 2. Then you have square root 7x plus 2. And this side is what? Is root 3x plus 2. So let's put x equals to 2 and see. If you put x equals to 2 here, we have 2. And this will be 7 times 2. This is 14 plus 2. So let's finish it up. This is 2 multiplied by root of what? 16. And so this is 2 times what? Root of 16 is 4. So we have root of 8 on the left-hand side. Now, the right-hand side, we are also substituting x equals to 2. So this is 3 times 2 plus 2. And this will give us also root of 6 plus 2. So this is also root of what? Root of 8. So the left-hand side is equals to the right-hand side. So it means x equals to 2 is a solution. Now, we check with x equals to minus 2 over 9. So minus 2 over 9, we will have this. So here we'll have 2 root of what? 7 times minus 2 over 9 plus. So the right hand side, what do we have? We have the square root of 3. And don't forget x is this, so we have minus 2 over 9, then plus 2. So let's simplify both sides. And here we can write this as 2. And this will be root of what? This is multiplication, right? This is 7 times minus 2 will be minus 14 over 9 plus. Now this is 2. Since the denominator here is 9, we can just write here as 18 over 9, which is still the same. So this is 2. And now we can write this as what? Minus 14 plus 18 over 9. And we can simplify this as 2 minus 14 plus 18 is 4 over 9, right? And now this will be root of, this is 4. This is like 2 times root of 4 is 2. And the root of 9 is 3. So we will have from the left hand side, we will have the square root of 4 over 3. Now let's go to the right hand side. The right hand side is, this is minus 3 times minus 2. This will be minus 6 over 9 plus 2. So the same thing, we can write this 2 as what? As 18 over 9. And this we can write as minus 16 plus 18 over 9. And this is minus 16, minus 6, sorry. This is, minus 6, not 16 here. This is minus 6, not 16. So you have minus 16 plus 18, and this will be 12 over 9. And this is 12 over 9. Remember, you can reduce this to what? Divide both side by 3. This will be 4 over 3. So root 4 over 3 is the same thing as root 4 over 3. So the left hand side is the same thing as the right hand side. So it means that both x equals to 2 and x equals to minus 2 over 9 are solution of our radical equation. So our solution sets, you can put them here. This is 2 and minus 2 over 9. So this is the end of this video. Thank you for watching. I hope all the questions are clear. Thank you once again.